Bye. Hi guys, how are you? Johan, was the homework doable?
Yeah, sure.
Okay. See, this class can run for a little more than the pre-algebra because we have a lot to do. Yep. Okay. Ashwik, was the homework doable? 13.1 and 2.
Yeah.
Okay. Ritisha, I missed you last week, right, ma?
No, I was here last week.
Oh yeah, you were there last week. Sorry. We did discuss regarding the forms as well, right? Yes, yes,
Yeah,
yes,
my
yes.
mother said she paid it, so
No, only the forms I discussed with her after that.
okay.
You coming on the roster is important for me. Otherwise, you'll miss all the emails and stuff, right, ma? That was my main thought.
Yeah, I'm
I
thinking
think she got it. Meaning, she said she did it. That's fine. You see,
yeah, my
so I
mom
don't
said she
want you
did
to
it.
miss out on any emails.
I think I'm missing like the session 3 email with like the dates and everything for this
Oh,
session.
you're missing?
Yeah.
See, I told you.
I was
Because
looking for it right now.
that's why when sending the email, I did not see your name. That's why I asked you. Okay, I'll check. I'll check after the class. Okay.
Thank you.
See how good. I'm happy that I got it. Okay.
Oh,
Okay.
also, I wasn't able to do this week's homework. Could I give it to you by next week?
Sure, ma. Definitely, but do.
Okay, I will do.
Sure. Okay. Parabolas and circles are quadratic optimization is hard. See, we have a lot to complete in this class. Transformations, exponential functions, logarithms, radicals, absolute value, piecewise functions, arithmetics. Oh wow. Okay, let's see. You all remember the quadratic formula? You all remember the quadratic formula? Let's
Yeah,
see.
I
Yeah.
memorized it
You memorized it. Good job.
because like I in one of the practice competitions that we did, I forgot it, so I like just like memorized it.
That's good. That's very nice. Let's see this one. Hmm. What are they doing in school, guys, for you all? Meaning you're all learning algebra, right? What are you doing in school?
Um,
Yes, Ashwik, go ahead. Yeah, go ahead. Go ahead. Go ahead. No, no, some of you give me inputs. What is going on in
Well,
school?
for me, next week I have my midterms, but lately we were learning absolute value functions. That was the last one we learned.
Oh, is it easy for you, ma?
Yeah, it was similar to I think you taught something similar like the K and H, like finding the vertex, that part I found it easy.
That's nice. Good. Vidyut, what are you learning in school?
Factoring quadratic equations. We had our quarterly this week.
Is it easily coming along?
Yeah, it's really easy.
Okay. Would you be able to complete square and finish this problem quickly? Complete squares and finish this problem quickly. Let's see. Let's see whether you're able to find the roots. Because here you need to introduce I. Oh, this is a good one. Let's see. You get it? I didn't see it.
Wait, Priyanti, what were we supposed to find again?
You're going to find the roots of the equation. That's a little tricky though.
The roots?
Yeah.
Oh, the roots. Oh, okay.
Oh, I thought you were asking for vertex.
By completing squares. By completing squares, please. Don't do anything else, okay? Now we are going to learn only completing squares, please.
Randy,
Yeah, ma.
how do you write plus or minus on on the keyboard?
How do you?
Write plus or minus.
Oh, you can say plus or minus.
Oh, just
Plus
write it out.
or minus.
Oh, okay.
Make sense?
Mm-hmm.
Okay. Oh, wow. Johan, good job, Johan. You're working through all the problems at home, Johan.
Yeah.
Very nice. How are you doing in school?
Oh, it's really easy right now.
Oh, nice. Very perfect. Very nicely done, Johan. Please give it to me as fractions. Please give it to me as fractions. Not really, Vishnuram. Where are we getting stuck? Johan, did you use completing squares?
Yeah, I did.
Okay, so you used only these two terms. Only when you do the homework, you'll be able to do whatever we are asking to do here.
What I just did is I just divided both sides by 5.
Oh, nice. That is nice. You just divided both sides by 5. Good job. So by making the x square coefficient 1, right?
Yeah.
Nice.
Randy.
Yeah, perfectly done, Vidyut. But there is something important. Did you forget to type something? Just check. You're right, but there is something missing. Did you see that? Yes, Ashwik.
Oh, yeah. I see it.
What was that was missing? Can you shout out what was missing?
The I.
Good. Okay, good. So you did it. Okay. Ashwik, perfectly correct. But that can be simplified, you know. If you can see, okay. Ashwik, when you're getting this, right, Ashwik, immediately you know what you need to do. What is it divisible by? Is it a prime number? No, it's not a prime number. 7 plus 1 is a 9. So it is divisible by 3. So can you write out the prime factorization and check whether it is simplifiable? It is simplifiable. Can you check?
Okay.
Hey, how are you doing in school, Ashwik?
Well, I'm doing good.
Good. Oh wow, Ritisha, correct. Very proud of you guys. You know what? Algebra 2 will be so easy at school for you guys.
Wait, Priyanti,
Yeah, go ahead.
were we supposed to use completing the squares?
Yeah.
I used the quadratic formula.
Yeah. Completing squares is quite important as we move up.
Okay, next
I'll
time
tell
I'll
you.
use the
Okay, I'll
completing
tell you.
squares.
No problem. You
Yeah,
can take
same.
out
I
the.
use quadratic formula, not completing squares.
You also didn't use completing squares.
No, because I kind of forgot how to do it, but I remember quadratic
Same, I
formula.
kind of forgot how to do it.
Okay, I'll
Yeah.
do it. See, that is quite important, right? Johan, you used completing squares. Can I confirm?
Yeah, I did.
Okay.
So
Take
then
out
if it's
5 as
not,
common. You should always have the x square coefficient 1. Okay, then only it's better for completing squares. When you take out that 5 as common, this becomes 3 by 5 x plus 9 by 5. Okay, equal to 0. Swarit, did you get the answer? Sham, very nice job, Sham. So,
solving.
okay. Sham, did you use completing squares or quadratic formula?
Squares.
Oh, completing squares?
Yeah.
Lovely. Okay. I took out 5 as common. So you're getting that. Divide by 5 on both sides, the 5 will go. Okay, guys? Divide by 5 on both sides, the 5 will go. Now, how to finish completing squares? Take these two. Okay? You need to make up a square term. Square term means 2 square, 4 square, like that. X plus 2. Binomial square you have to make. Anish, where are we, Anish? Did you get it?
Yeah.
What did you get? What was the answer? You're working on,
Still trying to figure it out.
Okay, so now I'm going to take the first two terms. How to complete square? I told you, right? You have to add and subtract some number. What is that number? B by 2a the whole square. Okay, so that is b 3 by 5 by 2 the whole square. What is it? 3 by 10 the whole square, which is 9 by 100, right? So to this x square plus 3 by 5x, I will add a 9 by 100 and subtract a 9 by 9 by 100. Why? So that this will become a square term. Okay, if I add something, you have to subtract something, so that it's like adding a 0. Okay, I'm copying this 9 by 5 equal to 0. Now this becomes a square term. What square term it is? X plus 3 by 10 the whole square. Now I can combine these two. How to combine these two? Minus 9 by 100 plus make the denominator 100 by multiplying by 20. So 20 times 9 is 180. Now this becomes minus 171 by 100. This becomes x plus 3 by 10 the whole square. You got it? I got this equation. Now what do I do? Once I get this equation, it's very easy to solve this equation. How? I can say x plus 3 by 10 the whole square equal to 171 by 100. But I can go ahead and take square root on both sides. Whenever I take square root, I need to be careful. I'll insert a plus or minus, right? So x plus 3 by 10 will be equal to square plus or minus square root of 171 by 100. But 171, see, if you prime factorize it, you get 3 5s are 15, 7, 3. Again prime factorize it, 7. 7 plus 5 is 7, 8, 9, 10, 11, 12. So it is still divisible by 3. So you get 3, 3, 19, which is becoming 3 root 19 by 100. Right? So now I'll put minus, I'm sorry, when I took the square root, I did not make the square root of 100. So now I bring this minus 3 by 10 to this side, plus or minus. So x will be equal to, and what was that? Something is wrong. I is not
I.
there.
Yeah.
Why? Where did the I go?
Wait, I just think you messed with the signs when adding negative 9 by 100 plus 180 by 100.
Oh yeah, it's supposed to be a positive 9 over 100.
Yeah, I use that, and 9 by 100 is here, minus 9 by 100
Yeah.
is here.
Oh,
The
look,
one
when we
3
added,
times.
yeah,
Okay,
It's
x
supposed
is
to be
supposed to be positive.
Sorry, this one is a plus, right?
Yeah.
So this was a there was a minus in here, minus 171, minus 171, and then there was an I here. Because of that square root of negative, that is written down as I, and then you have square root of 171 is 3 root 19. So the roots are minus 3 by 10 plus or minus 3 root 19 I by 10. Any questions? Diya, did you get it? Guys, if you are able to solve all of this, algebra 2 is so easy. School level algebra 2 will be very easy. Can I move on? Okay. I'm not that convinced. I don't know why. Okay. But let me see. I'll give you one or two more problems I feel. Let's see. How about this? Okay. You can use. Okay. Yeah. How about this? R squared plus 4r equal to 96. Get the roots. You can use quadratic. Please use the method I designate. Okay, then only you'll get used to it. Use the quadratic formula on this. You have to be good with every method.
Do we get the roots again?
What is that?
Do we find the roots again? Wait, or do we solve it, right? We just solve it?
Yeah, you have to solve it.
Oh, okay.
Mm-hmm. Good job, Diya. Aha, how did you do that? Vishnuram. No, how did you do that?
So R squared plus 4R, so I saw like a video to do this. So I divided the 4 square. So 4 squared divided by 2 equals 2. So I just added 2 square on each side. After that, I did R plus 2 squared equals 100. And then
Wait. What did you do?
you add 2 square on each side.
Okay, that's fine. Let's add. Uh-huh.
Okay, yeah, and then I saw this video. It was like telling me to do R plus 2 squared after this, because so you have to add the R and then and then you add the square for that, yeah. Yeah. And then you take the roots and then you get
Yeah.
R plus 2
R plus
equals
2 will be equal to plus or minus?
10. And then oh yeah, plus or minus, I forgot about that. And then R equals plus or minus 8.
Yeah, but your answer did not tell that, right?
Yeah, I put R equals 8.
Okay, good. No, you have to say both the answers, right, ma?
Yeah, I know. I was gonna put it, I just forgot.
Ritisha, did you get that answer? Oh
Yeah.
my god, I know what you did. What did you do, Ritisha? I know what you did. You should not do that. That is an example of what you did. What you did.
Oh. I have no idea.
No, tell me what you did. Then we'll all know,
Oh,
right?
oh, like how I solved it?
Mm.
I just like plugged in B, A, and C into the quadratic one and then solved.
You
And then
plugged.
I think at the end, if it's like the 2 square root 23, if it's that part, then like I
The
just
problem
cancel.
is you did not see in this form. Did you take A equal to 1, B equal to 4, C equal to 96?
No, I took C as negative 96 because don't you have to move it first?
Yeah, that's what I did too.
Yeah, you have to take C as negative 96. Then you will not get that. Did you use, okay, you use quadratic formula. You're saying minus B plus or minus B square minus 4AC, right?
Yeah.
Wait,
Uh-huh.
wouldn't C be negative?
Oh wait, is it? Isn't it?
Oh, never mind, never mind.
Isn't
I think I might have
96
done.
negative?
Yeah. C
Isn't
is
it
negative.
16
This is
minus?
incorrect. C is negative. That's why it became a plus here.
Yeah.
So divide by 2A minus 4
Oh,
plus or
I
minus.
know I did. I think I did minus 16 minus the 4 times 96 rather than plus.
Yeah, that's the problem.
Okay.
Okay, so
Sandy,
Yama.
did I get it right?
So the answer was what? Wait, I was checking the answers. I didn't check for everybody. Diya got it. Diya got it. Ashwik got it. Vidyut got it. Johan got it. Swarit got it. Nice. So if you use quadratic formula, everybody is really nicely solving. So the answers are plus 8 and minus 12. Can I move on? The Anish, I'm not getting answers. What's going on?
Solving.
Okay. How about I really wanted to give you some complex roots and see. Let's see. I don't want to, but I don't want to dwell on this. Let's see. Let me move on. Okay. How about this? Okay. Okay. See whether you're able to solve this. One thing, guys. When you're given an expression x by x minus 1, always right in mathematics. Suppose let's say a function is this. A function is given like that. Then what can't be the input to this function? Meaning I am trying to find out the domain of this function. Whenever I want to find the domain, I have to say what x value can't be. What input can't be given to this function.
1.
Good. Why 1, Johan?
Because then it would be undefined.
Exactly. So if I put x equal to 1, always look at your denominator if it has 1. So when I put x equal to 1, the denominator will become 0 and mathematically division by 0 is undefined. Got it? So if I have a function like this, right? What will be the domain of this function? What will be the domain of this function? In the sense, I don't know how to, let's say, let me make it simpler for you. F of x equal to 1 by x plus 5. What, see, when I make this function, when you graph it, right, let's try to graph it, okay? I don't mind graphing it quickly, okay? Let's put a minus 10. Minus 10 is in here. Let's put a minus 10, so it's a minus 5, right? Then let's put a minus 1. If I put a minus 1, it's 1 by 4, right? 1 by, when I put a minus 1, it's 1 by 4. When I put a minus 1, it's 1 by 4. It's not making any sense to me. Hold on. Minus 10 is a minus 5.
Oh,
Yeah. Okay, guys, wait. Before that.
Miss Priya,
Yeah. Go ahead, ma.
could I say the answer for that one? Because I kind of knew it.
Okay, you can say we will come back to it a little bit later. How about 1 by x? Can I try 1 by x? I want to see the graph of this function. What will be the graph of this function? I'll come back to you, Ritisha.
Mm-hmm.
How about this? What will be the graph of this function? Let's put down some numbers. Minus 10, minus 5, minus 2, 2 or 0, then 5, 10. Let me put these x and y values and try to graph it. What will happen? Minus 0.1, minus 5 means minus 0.2, minus 0.5, 0 means undefined. Correct, guys? Y equal to 1 by x, right?
Yeah.
5 is 0.2, 10 is 0.1. Make sense?
Mm-hmm.
Minus 10 is a minus 1. Very, very near, right? And then minus 0.2, a little bit up. Minus 0.5, right? And then 0 is undefined. So basically, undefined means it goes somewhere here, right? Now what happened to this function? Meaning 0, 5 is 0.2, 5 is 0.2, and then now somewhere here, and 10 is 0.1. So what happens? See, when it goes here, then again it comes from here. This is what is undefined. See, at the point 0, right, the function is not present at all, because just before that 0, it goes, at 0 it is undefined. So when you put a minus 0.9999999, 1 by minus 0.999999 is such a small number when you look at it. So it goes on like this, thinking that it will touch the y-axis, but it will never touch. Similarly, when you put here, this side, if you put plus 0.99999, your y value becomes 1 by 0.9999999, which is such a small, which is 1 by 0.999 is a big value or a small value?
No.
Hmm?
No.
1 by 0.1 or 0.99999. One minute, guys, 1 minute. X value, I can't put 0.999. Wait, let me put whatever is nearest to 0. 0.00000000000000001. So I put 1 by 0.000000000000001. Will it be a big value or a small value?
Big value?
Big value. So somewhere, I don't know, near infinity is there. So from there it is coming. Do you see it?
Yeah.
So yeah, instead of putting 0.999, put 0.00, because that is what is nearest to 1, right? 0.0000001.
Hey, Auntie,
Yama?
is this like called a hyperbola or something like that?
This is called a rational function.
Oh.
Okay, meaning I just want you to understand how to draw a graph. If you're given a function, you should know to draw a graph. Okay, you'll put down some values, and this is what means it is. This is what it means. The function is undefined at 0. See, it is going to minus infinity. Again, on the right side, it will come from minus infinity. So at that 0 point, the function is never defined. You don't have the graph at that point. You got it? Why? See, when the denominator becomes 0, the function becomes undefined. Got it?
Mm-hmm. Okay.
Suppose we'll go to Ritisha's problem. 1 by x plus 5. What will be... So, this I forgot to say, sorry. In this function, we did, right? So what is the domain of this function? Minus infinity to 0, and then 0 to infinity. Minus infinity to 0. But 0 cannot be... I cannot say 0 is a point, right? So I use a parenthesis. This side is also a parenthesis. Again, 0 is not included. It's a parenthesis, infinity. You got it? Union means I'm also including 2, meaning this as well as this is a domain. But at 0, the function is not defined. That is why you use a parenthesis. Meaning, okay, let me show you. In a linear graph, if you have a function like this, let's say, you have a function like this. What is the domain? What is the domain of this function? What is the domain of this function? Who can tell me the domain of this function? Domain means all possible x values. What is the domain of that function? Tell me, guys.
Wait, what's the other? Yeah. Okay.
I put everything. What is the domain of this function? Just a line. Domain means all possible x values, right?
Negative
Negative.
is
Negative 1 is
less than or equal to
or equal to
x.
x is less than what sign comes here on the right?
Less than.
Less than 5. See, you're putting one side less than. One side you're putting less than or equal to. What does it mean? Minus 1 is included in the graph. 5 is not included in the graph. So, another way of saying this is minus 1 comma 5, all values are included. The lowest interval, highest interval. However, this is inequality you're writing, right? You can as well write it as in interval notation. Like using intervals, you can write it. You can just say the starting, the ending. However, since it is less than or equal to, you can use a square bracket and tell that minus 1 is a part of the function. This 5 is not a part of the function. Make sense, guys?
Auntie,
Yeah, go ahead.
for infinity and negative infinity, don't you use the parentheses too?
Good question. You can never touch infinity or negative infinity, right? Always, whenever you have negative infinity or infinity, you have parenthesis. Make sense?
Mm-hmm. We had a test on this.
Oh, wow. Good that we discussed. How did you do?
I got 100 on it.
Oh, nice. So, but did you understand why you cannot use square bracket on infinity minus infinity? Because we
Yeah.
don't even know where is this point. You got it?
Mm-hmm.
Nobody can touch minus infinity or infinity, so you always use a parenthesis. The parenthesis and the square bracket are a big thing when you get into algebra 2. You should never make mistakes. Okay, one side it might be square brackets, another side can be square bracket or parenthesis. Make sense? But that's what this is, less than. This is less than equal to. Make sense?
Mm-hmm. Yeah.
Okay, tell me what is the range of this function? It's just a review, right? What is the range of this function? Who is going to tell me the range of this function? Shout out, guys.
4 is.
I'm sorry, this is minus 4, right?
Minus 4 is less than or equal to y, which is less than 2.
Okay, in interval notation?
Negative
Square bracket
negative
-4.
Yep.
comma
And
comma,
comma 2 close
open
parentheses.
parentheses.
Is this okay? Good job, guys. So this is the initial start of algebra 2 for you guys. Domain range, you should know how to write it in inequality notation, interval notation. Another notation, you'll have set notation that you can learn it later. Okay? Can I move on? Okay, how about... Yeah, go ahead.
Isn't set notation like this union, this?
You want to know set notation? I'll explain that as well. Not a
I already
problem.
learned it, that's why.
Good. Set notation means it's like, see, okay, let's say there is a set 1, 2, 3, 4, 5. I'll just give you a brief intro of sets, okay? This is a set E. Let's say a set means a group of numbers. One set is always using this curly braces, okay? So a set E uses numbers 1, 2, 3, 4, 5. Another set F is there that has 1, comma 2. Okay. This is a very brief intro on sets just to make you a little bit aware. Okay. 1 second. Meeting? Okay. Morning 9:06. Okay, guys. There is a set 1, 2, 3, 4, 5. There is another set 1, 2. Okay. Here, if I say E union F, that means I have to include all the elements of both the sets. I'll write 1, 2, 3, 4, 5. Make sense, guys? Union means you have to cover this or this. Any element that is in E or F, you'll have to put it in union. Suppose if I ask you what is E intersection F means, what is matching between them? You'll say 1, comma 2. Make sense? Make sense?
My teacher thought it through a Venn diagram.
Very nice. Okay. Venn diagram is a nice one. This is E, but here it cannot be two different circles because 1 and 2 are present inside. Now, intersection means whatever conflicts or whatever coincides. Union means it is the sum of all, both the sets. Make sense? That is enough. Okay, now for the same question, if I want to write it in set notation, let's say I want to write the domain in set notation, you know what I do? I just put two curly braces, okay, and say, hey, I'm talking about my domain, okay, and then a pipe symbol. This is all very common across, okay. Now you're going to write the restriction, you're just going to write it here, meaning this one you're going to write it here, meaning what are you going to write it here? -1 less than or equal to x is less than 5. Make sense? Inequality notation, you can just straight away use it, but you have to say whether you are referring to domain or range here, and then a pipe symbol with its restriction. Here, if you want to say the range, right, again square bracket, if you talk about range, you have to say that you are talking about y, then a pipe symbol, then what is your restriction? -4 to 2, right? So it is just an intro, guys, nothing is in this book, but you need to be able to write domain, range and domain and range in all the three notations. What notation? Inequality, interval notation, set notation. Make sense? Okay. I did not give you, meaning I did not tell you so many things in sets. I'll just move on. Okay. How about this? Okay. How about this? Find all real numbers. Find all real numbers such that x by x minus 1 plus 1 by x minus 2 will be equal to 3. Would you be able to take it by yourself? Do you think you can solve for x by yourself? Check. It's not hard. But you have to take LCM, guys. Should be able to take LCM. LCM means, see, 1 by 5, 1 by 7, what is LCM? There is no commonality. Just multiply both of them. That's the LCM. You got it? It's like a 1 by 5, 1 by 7, right?
Pencil broke. Could I get a
Go
new
ahead.
one? My pencil broke. Could I get a new one?
This one I would like to see some answers which have not yet come. Let's see.
Hello? Can I go get a pencil?
Yeah, ma. Wow. Okay, guys. I think you're all good with all this. Okay. Good job, Ashwik. You're also following every problem in the book, Ashwik.
Yeah.
Are you doing alchemist?
Yeah, I am.
How about you, Johan? Are you doing alchemist, Johan?
Yeah, I'm doing all I can for that.
Oh, okay, that's fine. See, at the end of it, it's not a mandate, okay? But definitely, whenever you have time, do 10 problems. Okay, see, now you won't realize the advantages of all this. When you go to college, see, even if you finish multivariable calc and go to college, there are kids that are suffering with, struggling with math. Okay, that foundation problem will not be there if you keep practicing now itself with all these. Ritisha. Is that what is inside the square root is right, Ritisha? Check. Ah, Sham, your whole number part is incorrect. Vishnu Ram correct. Very nice, guys. Very proud of you. But Diya and Anish, I'm waiting. Amma, please send in your answers, guys. Swarit, this time I want your answer. I'm going to wait.
Miss Priya, I sent my fixed answer.
Priyanti, is that my answer?
Yes, ma'am. Oh, yeah. Ritisha, correct, Ritisha. Vidyut, where are you getting these values? What did you do?
I have no idea.
Diya, Diya as well. The main whole number is incorrect for both of Vidyut and Diya.
I
Okay,
got a
guys.
number. I got an equation, but
What is it? See, did you take LCM?
I can
See,
show
for
you.
this and this to have the same denominator, this fraction should be multiplied by x minus 2, right? Let me put it in another color so you're very clear with what we are doing. I'm multiplying this by x minus 2. Okay, I'm multiplying this by x minus 1. You got it?
Yeah, I did that.
Yeah, good. And then you get x minus 2, x minus 1 in the denominator. Numerator, what happens? X square minus 2x. This numerator is x minus 1 equal to 3. Now x square minus x minus 1 will be equal to, what is this? 3 times x square minus 3x plus 2. Can I say that? Now 3x square. Okay, let me put it down slowly one by one. Where are you making mistakes? Three of you have made mistakes. One has not answered. What's going on, guys? 9x plus 6. 2x square minus, am I doing it right? 10x plus 7 equal to 0.
Miss Priya, wouldn't it be x squared minus 3x minus 2
Minus
on
2.
the left side?
On the left side, x square minus x minus 1, right, ma?
No,
Wait.
because if you multiply x minus 2 times x minus 1, wouldn't you get plus
Oh,
2?
on the right side, this side,
Yeah, left side. No,
that is right side.
sorry, I was
No
confusing.
problem. No problem at all, ma. X square, see, we correct each other, no problem. X square minus 3x plus 2, right, ma?
Yeah.
3x square minus 9x plus 6. So that would be 2x square. I'm moving the x square to the side, 2x square. Then minus 8x. Oh my gosh. Minus 8x plus 7. So 2x square minus 8x plus 7 equal to 0. How do I solve this? Minus b plus or minus b square. Right? Minus 4's are 8, 7 8's are 56. Divide by 2a. So 8 plus or minus 2 root 2 by 2 by 2 times 4, 4. So that gives you 2 plus or minus root 2 by 2. Diya, did you get it? Diya, did you understand why you got 2 plus or minus? Vidyut?
Now I understand it.
Okay, Anish, where
It's a
did you
weird
make the,
method.
which one?
I see what I did wrong because for x squared minus 2x plus, I did instead of the plus x, I did a minus x. That's what went wrong for me.
I see. Anish, where did you make the mistake, Anish?
Um, I
Tell me, where did we make the mistake?
multiplied like the equation, and
Uh-huh.
yeah,
You multiplied it. So where was your mistake? Solving the quadratic, or where was your mistake? Yeah, I'm here. I'm here listening to you. Tell me, where was the mistake?
solving the quadratic.
Oh, in solving the quadratic. Okay, okay, good to know. Guys, I have questions for you. Can you educate me? Have we solved parabolas and transformations? Did we discuss parabolas? I am going to refer old notes, but tell me, have we solved parabolas in class earlier? Guys, yes, no, anything is okay.
So,
Huh?
I think we covered it maybe once.
it was
Sir?
really brief.
Sorry, Johan, I didn't get you.
I think it was really brief or something.
Really brief. Okay, we want. Yeah. I want to know. I want to do it properly. Did we cover inverses?
Yeah.
Inverses we covered, right? Composition and inverses we covered, right? That's good. Okay, let's do. Okay, so the thing is, I want to do quadratic optimization, but we can do that later. Okay. Quadratic formula we did, applications and extensions we did. Okay, so completing squares is such a good thing. You have to do a lot of problems on that. Okay, now if I say y equal to x square, right, do you know how to graph it? If I say y equal to x square, do you know how to graph it?
Mhm.
Okay, great. Can I go ahead and do the graph like this? Meaning, what do? I'll put one input and output. Input is my x, output is my y. I'll put some negative values, okay? Some negative values, okay? And then a 0, some positive values. This is the easiest, so I'm putting them. So, y equal to x square, right? 4, 1, 0, 1, 4. So, the graph will be like this. Make sense, guys? Okay, now how about this? Suppose if I give it to you like this. What is this? What happens? Do you see some transformations happening? Okay, let's not worry about this. This is a little complicated, okay? I'm going to go ahead and give you this. Y equal to minus x square. What happens, guys, to my graph?
It'll
It'll
be
like flip
down
around.
Flips.
Yep, flips on the.
x-axis.
Yep, this minus indicates a reflection on the x-axis. Suppose if I give you y equal to minus x, then I square it. This means I changed my x coordinate to a negative value. This means I changed my y coordinate to a negative number, meaning there is a point here. Let's say this is 1, 2. If I flip it on the y axis, what coordinate changes? If I flip it on the y axis, my x coordinate is negated. If I flip it on the x axis, my y coordinate is negated. Do you see the opposites are getting negated? Am I making sense with this, guys? Okay, so here my y got negated means I'm flipping it on the x axis. Here my x got negated. So the graph is going to be just the same, because if you flip it on the y axis, it's just going to stay the same. But when you see, if you see the minus, the x was negated and then squared, right? This is like introducing a negative on the x coordinate, which means I'm reflecting on the y axis. Any questions, guys? I'm going to ask you so many questions. That's why I'm giving you so much of detail. Reflect on. x-axis. Got it? So reflection is over, right? Now let's do this. Y equal to x square plus 4. What would happen to the, see, I'm adding a 4 to what? My parent graph is this, y equal to x square. When I add 4 to the y, what would happen to the graph? Who can guess? Guess.
It'll go up.
It'll go up by 4. Good job. Okay. Now, if I have a graph like this, y equal to x square minus 4, what happens to the graph?
It'll go down by
goes
4.
down.
Yeah, it'll go down by 4. Got it, guys?
It's kind of like y-intercepts.
Correct. Now, let's try this one. Y will be equal to, let's say, x minus 2 the whole square. That's a little tricky. What happens here?
It goes up by 4?
Huh?
Does it go up by 4?
See, okay. When I do this, I add the 4 to the y value. When I do this, what I'm doing?
Moving to the left.
Moving to the
Good.
right.
Moving. Two different answers. Moving to the left or right?
Left?
Right.
Okay, there's 2 left and 1 right. Which is correct? Okay, let's find it out. Okay, this is a little tricky. That's why I want to concentrate on this, show what is happening. This is very easy. This is very hard. Okay. X, y minus 5. Then I'm going to have minus 3, 0, 3, 5 this time. Okay. Minus 5. This is x minus 2 the whole square, right? So this is 49. Minus 3, if I plug it in, 25. Then 4. For 3, if I plug it in, it becomes 3. If I plug it in, what happens? 1. And then 5, if I plug it in, 5. If I plug it in, 9. I can also plug in a 2 and see so that I get some answer. Okay, 0. Now minus 5 is a 49. Minus 3, minus 5. Minus 3 is a 25. And then 0 is a 4. 0 is a 4. Okay. And then 2 is a 0.
Wait, it gets wider?
Huh?
It gets wider?
No, Amma, it doesn't get wider. Please, don't take it like that. Okay. I drew it that way, I feel. Okay, let me change it. Okay, I don't want to confuse you. Let me do it, please. No. Okay. 1, 2, 3. If I didn't draw it properly. Okay, now minus 5 was a 49. Minus 3 was a 25. Somewhere up, right? And then 0 was a 4. Let's say this is a 4. Okay, 2, 4. Let's say this is 2, 4. Like that. Okay. This was a 4. And then 2 was a 0. So what happened here? It became like this. Did it move to the usual parent graph is what? Parent graph is always this, right? Meaning it moved to the right. So please, this is a little different from the normal. When there is a minus x minus 2, it moves to the right. Then how about this? What sort of a graph is this?
It's gonna move left 2 units.
Exactly. The graph of that will be represented like this. This is 2 units. Got it, guys?
Yeah.
Okay.
Miss Priya,
Yeah.
we didn't learn like this. We didn't learn quadratic functions yet, or like graphing them. But our teacher did teach us. Like if it's in parentheses and it's -2, then it goes to the left. If it's positive, it goes out.
Oh, nice. How about this? Y will be equal to 2 times x square. What is this, guys?
Like make it narrower.
Very nice. Make it narrower. Very nice. Yes. That's okay. Oh, iduva. Oh. Y equal. So this is my parent graph. Let's say this is my parent graph. See, y value is getting multiplied by 2. That means what? Let's try it out, guys. Minus 1, 0, 1. Okay. So your original y equal to x square graph would have had what? Would have had 1, 0, 1. Correct? So minus 1, comma 1, 0, comma 0, 0, comma 0, and then 1, comma 1. So this is the original graph. Now I am going to go to this graph. 2x square. Y will be equal to 2x square graph. How will it change? See, y will be equal to 2 times x square, right? 2, 0, 2. So what happens, you see, when x was minus 1, this is minus 1, y was a 2. Do you see what happened? Again a 0. See, it became narrower because it became steeper. The 2, the slope increased, right? It became steeper. Did you see that? So vertically, see, this is what we call vertically look. See, think of this like you're holding the bottom of the U and pulling it down. When you pull it down, when you pull this parent graph like that, vertically, vertically what?
Right.
It's like whenever you're holding.
One is vertical compression, vertical stretching. Yeah.
Mm.
Vertical stretch by 2. You're stretching it, like think of the bottom of the U is being pulled down. Automatically it will get thinner, right? Okay, suppose if I put y equal to half x square, all my y values are getting multiplied by half. So what happens to the graph?
Vertically compressed by
Wider. It will become wider like that. So how do I think of this? How do I say this? Vertically, you are compressing by half. You see, half is less than 1, so it's a compress. Vertically, you're stretching by a factor of 2. So, what is this vertical compression? Vertically means what are you doing? You're patting the graph up and down. See, you're doing it like this. You can see my video. Up and down, you're patting the graph. So, what will happen? Vertically compressing means it will become fat and fat. That's how I remember. You'll never forget all this. Got it? Did you all get it, guys? Okay, great. Last one, should I introduce now? I don't know. Let's see. This one. Y will be equal to, this is a little tricky. Just like the negative sign inside the x, right? Inside the parenthesis, right? This is a little tricky. How about this? What will happen to this? What will happen to this? What are these? You are multiplying your x coordinate by a 2. So what will happen to the graph? Will it be?
Does this one become better and become more?
Please be loud. What?
For the 2x squared, it'll like shrink and like become smaller. And for the 1 over 2x squared, that one's gonna what's it called? Become wider.
Exactly. So what is this? Horizontal, meaning whenever, see, in this case, I multiplied the half to my x coordinate. I multiplied the 2 to my x coordinate. That means I'm making changes horizontally. On the horizontal axis only I'm going to make changes, okay? If I multiply my x by half, horizontally what I am doing to the, this is my original u, okay? Nobody is going to change this u, this is my original u. But when I multiply by half my x values, what I am doing?
Horizontally stretched.
Horizontally I am compressing, horizontally I am, good, go ahead.
Right.
Horizontally?
Is it stretched? Or no, wait.
Good, horizontally I am stretching it. I am pulling the u on both the sides. So what happens to the graph? It becomes
wider.
Wider. You see? Whereas in this case, I am multiplying every x value by 2. So what happens?
It'll become horizontally compressed.
Yes, horizontally compressed by a factor of the reciprocal. Because compress means the factor has to be less than 1, right? So whenever you see, whatever you see inside the parenthesis, right? This is one way of remembering. Whatever you see inside the parenthesis, right? The number, the coefficient, right? You will find the reciprocal. See whether it's less than 1. It is less than 1, then it is compression horizontal. Here, find the reciprocal, greater than 1. So it is a stretch, horizontal stretch by 2. Make sense?
Auntie?
Yeah.
My math teacher in school said it doesn't matter about like the number, or if it's in the parentheses and it's horizontal stretch, you would just put horizontal stretch by 1/2 instead of, you wouldn't do the reciprocal.
That How, Amma? If you stretch something, your value is to increase, right?
Well, but like I don't know what she said about that, but like, cause like it's like similar, like
I
they're like
hear you. I
opposite.
hear why she's, meaning, why are you coming there? Okay, not to confuse you, maybe. But think about something is being stretched now. See, uh,
Yeah,
you see what I
no,
mean?
yeah, I
The
know what you mean. You would take the reciprocal,
uh,
but like,
the right way of telling why are we taking the reciprocal, I'll explain as well. You don't need to go that far, guys. Okay, why are we taking the reciprocal? When you think about it, the factor b. Okay, so we consider some. Okay, let's say here it is ax square. I represent this as ax square. Here, you know, in the general format, when we represent quadratics, right, the horizontal stretch is represented by a. Okay, the vertical stretch is represented by b. The vertical stretch is represented by b. B is in the denominator, so you directly take it and tell. You see what I mean?
yeah,
So I don't want you to confuse at all. Meaning, see, y will be equal to half x square. If it is like this, it's so easy for you to say, right?
yeah,
Vertical,
yeah,
vertical, vertical compress, vertical stretch, vertical stretch, vertical compress, half and 2. Okay. Whereas if it is like this, right? If it is inside only, all problems come. You have to find the x is always very problematic. Okay, when it has a minus, it goes to the right. When it has a plus, it goes to the left, right? So if the half is inside, it is a vertical stretch by 2. This one, like this, it's
wouldn't
a
that be a horizontal
yeah.
stretch?
Sorry, yes, horizontal stretch and horizontal. Why horizontal? Because the number is getting multiplied by x. Here the y value was multiplied by half, y value is getting multiplied by 2. I will go over this again and again and again for you. It will be so easy for algebra 2. Okay, algebra 2 covers every function. You will transform like this, meaning you know this is an absolute value function. They will teach you, hey, what is this, what happens to the graph, what happens to the graph if I do this? Again and again you'll be learning the same thing over and over again. That is why now itself you understand quadratic transformations well, then it becomes very easy. How about this? How about this? Y will be equal to, tell me, oh my gosh. We'll just revise this and then disperse, but we'll discuss this next week as well. Okay. How about this? Y equal to x plus 2 the whole square plus 5. What are the transformations, guys? Who can tell me? What are the transformations here? Y equal to x square graph. What happens to the graph? What happens to the graph?
More narrow, like stretch.
We'll start. What ma? Tell me.
It's
Stretch,
narrower and more stretched.
By
Uh,
2. Then
It'll
uh,
move left 2 units.
what is it?
this
It'll
would
move
the it
left
would go left.
Yup. Left by
2 units and up by 5.
up by 5. You know, when I want to graph it, right, you don't need to undergo struggle. Okay, this is my original graph, right? So think about this, think about the vertex. Okay, you said vertical stretch by 2, meaning automatically what happened to the graph? It became thinner, right? Fine. Okay, now left by 2, it moved here, left by 2 and up by 5. So what happened to the graph? Let me show you. The final graph was this. This is 5 on the y-axis. Got it, guys? This is 2 on the x-axis. Got it? Very easy to graph it if you start understanding these intricacies. Does that sound good? How about this quickly?
Miss Priya,
Yeah.
you have to go out somewhere.
Okay, you go ahead, ma, please.
All right, bye.
Bye, ma. How about this last one? What are the transformations? What is this? Reflection on?
X.
X-axis
Reflection on x opposite. This
and
one?
vertical compression
By
one
what is this? X is always problematic, remember.
gonna turn left
Mm.
5 or left 5.
Left by
Left
5. You got it?
Yeah.
You know, telling this We'll take the algebra 2 whole here. But once you learn for one function, then it's so easy for every other function. Even if it is a cubed root, square root, anything you can solve. See, they can ask you like this, they can ask you like this. It's the same thing. Okay, whatever x square was your function, here it is absolute value of x. If it is inside, outside. Same continues for all the functions. Make sense, guys? Yeah, I'm not expecting you to know any of these. Okay guys, I'll stop here. Okay, that was a good session. I always like coming to this class. Any questions, guys? Okay, but at least the quadratic transformation you should know. Okay, we did complete chapter 13. Please finish till review problems and come back. I will write it down in the classroom. Okay.
Bye,
Any
Priya.
questions for me? Bye, ma.
Actually, Miss Priya,
Yes.
when we were learning like absolute value functions in school, we had learned already like the transformations and reflections and stuff.
Oh, that's
Because
nice.
like our teacher taught us this basic formula. It was like whatever the thing is multiplied by, it was like a absolute value x minus I
This
think
one?
8. Yeah, that one. So that's how I like and then you can just apply it to everything else because similar.
Perfectly makes sense. You can even apply to ax square. This one is ax minus h the whole square plus k for that matter.
Yeah, I think you taught us that last time when we were
Oh
doing
yeah, quadratics, right? Yeah.
yeah,
So
that's
same
why I
thing.
remember that's why in school it was easy for me
Yeah,
to
same thing. Meaning the h only is causing that left and right movement because there is a minus h, right?
yeah, I don't
Yeah,
know.
yeah. Nice, Ritisha. You picked up very well. Good job.
Um, Thank you.
Thanks for letting me know. Bye, ma.
All right, bye bye.
Auntie,
Bye. Yes, ma. Tell me.
I have a camp next week.
Oh, okay. So you are going to watch the recording?
Yeah.
But Swarit definitely watch the recording, okay?
Okay.
Meaning, algebra 2, you don't have to study at school if you study this book. Honestly, I tell you.
Yeah.
Okay? There'll be some to learn, but you won't be pressurized at all. Okay? Because
Um,
completing squares comes in big time, complex numbers come in big time. Right? So you already learned it, so definitely go through the recording. Okay?
yeah.
Yeah. And,
Auntie, we didn't talk about scientific notation, right?
oh, okay. Yeah.
Because they were teaching that at school and it was like easy, but
You
is
want
it?
you want me to do that?
No, like I'm just asking because I didn't know it before.
Um,
So,
yeah, meaning since you went through this, usually I do that in grade 7 8 class, but you never
yeah.
attended my 7 8 class.
No.
Yeah, that's why you did not. You
Uh,
want me to cover that?
I mean, you don't have to. I mean, like in school, they like taught it like pretty
Yeah,
where I
for
can
us, yeah,
understand
I'll
it.
tell you, it's a part of grade 8 standards. I
Oh,
cover that in the 7th grade classroom,
okay.
7th and 8th grade classroom before Algebra 1.
Um,
Okay, that is because it is meaning it is an important foundation concept which is a part of grade 8 standards. None of you get to study grade 8, right? So I cover that in
mhm.
7th grade.
Okay.
Okay, but you
Mm,
finished your CB and we came into this book. We went through pre-algebra book and came to this book, right?
yeah.
This book does not cover scientific notation. That's my problem.
Okay.
But if you want me to cover it once, I can do.
Okay.
You want me to?
I think it's fine, but like it
But
just
good
like
to know.
looks
Good to know.
easy too.
Good to know. And that's the reason.
Okay. Thank you,
Got
Auntie.
it? Bye bye.
Bye.
Thanks for sharing, Farid.
Mhm.
Good luck. Good luck with your camp.
Thank you.
Watch the recording, do homework, come back.
Yeah, I will.
Bye bye.
Bye.